Welcome to From Cover to Code, the Technology Book Club. Join us as we discuss artificial intelligence, DevOps, software development, cloud computing, and more. With your hosts, Angela Andrews and Michael Jenkins. The next episode of From Cover to Code starts now.
And we are live and in the building.
Hello.
How are you doing today, Angela?
I'm doing.
Okay.
And I'm gonna leave it at that. I'm here.
Yeah.
I'm pretty much read into what we're getting into today.
Cool.
I'm just glad to be sitting here with you. How are you doing?
Yeah. I'm doing good. And let me tell you, it's the conversation we can have today is going to be blazing because my air conditioning is out.
Oh, we're not playing no games.
Yeah, the studio is hot today. Hopefully because, we have like some very interesting and just like really cool stuff to talk about and discuss. But otherwise, it's going to be hot because my air conditioner is not running right now.
Okay. We will not go long because we don't want to suffer. We don't.
I'll be fine. I got a window open. Just hope that like my neighbors aren't loud or a garbage truck drives by or, whatever the case is. But it'll be fine.
Life sounds. Okay.
Yes. Yeah. You'll get all the things from my neighborhood.
Okay. Well, we're here.
We're here in
chapter 4.
Chapter 4 of Terraform Up and Running by Jim Brikman.
Yes. The book.
And the book or the Kindle. If you're I got my Kindle version.
If you're listening, he's just holding up his cell phone.
Yeah. Yeah. Hey, I tell you what though, the Kindle version and the audiobook really got me through this chapter because we were talking about earlier. I was standing in line for a while yesterday and listening at 2x. Just kind of blazed through the reading. But we also talked about how listening to this book really wasn't sticking. We had to read the words to understand the code. So I'm listening, so I'm hearing it one way and I'm seeing it with my eyes and seeing the code and everything. So it really kind of attached itself to my brain.
Very good.
I got all this Terraform module stuff locked in and ready to go.
Oh, I love that. So, that is one of my favorite ways to consume like a lot of things. I will listen to an audiobook and read the actual book or the Kindle. I do that so much because I feel like it latches itself on. Like to your point, I feel like I'm remembering more because my eyes are literally doing the work of trying to read. And I usually speed it up a little bit because most what do they call them? Voice actors or whatever. They read really slow. They make a lot of tonal changes and it's like, your eyes are already at the end of the sentence, but speed it up and you read it just the way that your brain kind of registers just to me. And it sounds like you experienced that same thing. I love it.
Yeah. And I will say one other thing about if you were just listening to this book by itself in Audible, is the way that the narrator spells out some of the resources. And so he was literally reading the code, like
provider.
Yeah. Yeah. Open quotes, AWS _ resource name _ open bracket, so it's very difficult to listen to, envision those characters in your head and put them together so they make sense. So you really got to see it to understand what's going on.
I agree. Cool. Well, this chapter, this is modules, baby. This is definitely, it's up there. I thought state was like, oh man, we talked about state, but modules is definitely the creme de la creme. That is the thing that moves Terraform functionally across all of your environments. It makes repeatability easier. It's basically using like a function and calling
Yeah.
that function here, there, and everywhere. So I learned a lot on this one as well.
Excellent.
And it goes over this chapter. It's not a long chapter, but it goes over module basics, inputs, locals, outputs, some gotchas, and versioning. So
Mhm.
this is what we're going to dig into today. And let's start at the top.
Yeah, no doubt. And I will say before we get into the module basics,
Yes.
I appreciate that the author in 4 short chapters has brought us all the way through Terraform basics, variables, and like resource references, Terraform state, and now here we are. We're landing at modules. If you only read those first 4 chapters, you would be very well versed, probably more well versed than 75% of the people who touch Terraform in just those areas with just that bit of content. You can do a lot of damage and a lot of good just knowing that particular stuff.
Damage.
Good damage, good damage. That's what it is.
Okay.
Yeah,
I agree with you. This has
yeah.
been a supercharged, you know, introduction to Terraform. Supercharged. He did not mess around with getting you up and running. I mean, it is called Terraform up and running. So old boy was not kidding. And I think anyone who reads this book, who's serious about learning IAC, if you're into reading, he doesn't play around. He gets you from 0 to modules in just 4 short chapters. So shout out to the author of this book who,
Yeah.
you know, in his 3rd iteration, he really he did some things. How many
Yeah.
chapters are in this book?
You know, I want to say there are 10. If I was a better co-host on the show, I would have my
10.
notes up for the
You're right.
season. Yeah. Okay. So there's 10.
Okay.
So yeah, I'll pull that up so we can, so I can have that as a better reference. But yeah, 10 short chapters, and we're going a long way. Yeah, we're covering a lot of material. We're already almost halfway through, and we're at modules. So yeah, let's get into it.
Okay.
Well, module basics. I appreciate modules because as a child who grew up, but as a child who grew up with Legos, I see modules as the Legos. They're literally the building blocks of infrastructure as code.
Okay.
If you have this box of modules, which I kind of, correlate to a box of Legos, you can build anything. And the resources themselves, they're like little Lego blocks that you use to make the bigger module. And then you take that module and then you put it together with something else. And now you got a whole thing.
Okay. I like that analogy.
Yeah.
It's it's very visual.
Yeah. I was gonna say, let that kind of stick in your head too.
Okay.
At least that's the way that I think about it.
I got it.
And the other way, and I guess we'll get to it when we get to inputs and outputs. But just the way that you wire modules together. And I got some thoughts on that.
Okay.
But and I guess really the only thing you need to know about a module is that any set of Terraform configuration files is a module. If those files are sitting together and they're main.tf, whatever.tf, you got a module. It's all about how you reference it that really, really makes it a module.
That's true.
But by default, any Terraform code is already a module. You don't even have to do anything.
You don't. And if technically he said it, you've kind of been doing this all along, but now you were going to take it a step further and modularize the environment. So that was neat. That was neat. That was a analogy that I could get behind. He used the term a root module. That's the place where you run your Terraform apply. And I'm assuming that's the one where your providers are configured. So that's where when you're beginning, when you are defining your file, that's the root of everything. And if your folder structure is such that you're referencing your path back, that you're building out your module. So there's an image on figure 4.4 if you're in the book, page 19, that shows you how the author wanted you to kind of break out your code, and he did give a good example how you went from You had your global folder. We talked about that last week. Your stage folder. It's not on this page, but you'll have your production folder.
Mm-hmm.
And then, of course, the modules folder where both environments reference back. So this is good stuff.
Yeah. And
sorry.
No, yeah. The other thing that I was going to add about modules, and the author also alluded to it, is that in the corollary for Terraform to a typical programming language is a module is like a function.
Yes.
Where it has, a function, you give it some inputs, and then it returns a value. And a module is kind of like that. You have variables or other inputs that you give it. It does its thing, and then it returns outputs as a result of whatever infrastructure it built out. So it's literally just like a function, a Lego and a function. That's how I'm gonna.
These analogies are getting us far, but I did understand that they talked about, they gave an example of a function, and I was like, oh, this looks familiar. Okay,
Mm-hmm.
and then you're just calling it in the different places where you need this function to run. It makes your programming more modular. It makes your IAC more modular. So you're trying to keep it dry, as they say.
Yeah.
You're trying to keep it dry. So let's see. Did I see that somewhere else in here? I'm sure I did. But I can't find it. That's okay.
No, yeah, that's fine. Yeah.
All right.
But, I mean, yeah, that's pretty much it for module basics. It's just like it's like a function. You got your inputs, you got your outputs, and it does stuff. Any collection of Terraform is a module. You just have to wire it up.
They did say, though, once you start using modules, there's no going back.
I would have to agree with that.
Believe that? Okay.
Yeah.
Like once you bid, you got to keep doing it. And then you can build your own your whole module library to make your life so much simpler.
Yes. Yeah. And so that is definitely a best practice that I've done.
Good.
And I'll go all through it as we get a little bit more into the discussion. Okay. But since we're talking about it now, I did have one group that I wanted to shout out. And that is Cloud Posse.
What's that?
Which Cloud Posse is it's like a infrastructure as code consultancy. But a lot of the code that they produce, they share it open source on GitHub. So for the folks that are joining us live or watching the video of this, I've got their GitHub URL right here on the screen. I'll put it in the show notes as well, github.com/orgs/cloudposse/repositories. And if you search that location for AWS, you'll find that they have hundreds, like literally hundreds of modules that are opinionated in the sense that they have a very specific way of putting these modules together so that they form environments and applications. But they've also taken out all the effort for you of having to develop a module yourself. So if you need a module for a load balancer, you can go to this repository and find that module. For S3 bucket, for a server, for ECS, for EK, whatever AWS resources that you might have in mind to build something out, go here and take a look at the modules that they've built and shared. You can reference them in your code directly. I will say it's easier if you're following their approach for naming and for directory structures and all that kind of stuff. So if you've already built something out and you're trying to pull in one of their modules, it might be a little bit more difficult than taking all of their modules and starting from scratch. But I guess the other thing that I will add, if you take a look at their structure and see how they're working with it, you'll get a better idea for developing your own modules. And I've learned a lot just by reading the code in these repositories as I built out my own library of modules.
So this is a resource that you've used in your day-to-day.
Yes, it definitely is.
Oh, interesting. So they have it's 148. Is that true? And there's everything you can think of just for AWS. I'm looking.
Yeah, and they have other ones for like Google Cloud. I don't think they do Azure, but they do have Google Cloud stuff as well.
Oh, they got a little bit of everything. Okay.
They got it all.
I am impressed.
Yeah.
I am impressed. Yeah. So, and if you're not familiar with, creating modules or things like that, I'm assuming if you look at their repository, you will get inspired and you'll get ideas.
Yes.
And it'll help you figure out, well, this is how you create said module for this resource. Now, of
Yeah.
course, the documentation is always the best place to go, but this is absolutely like a leg up. I'm scrolling
Yeah.
through here and they got a little bit of everything.
They got it all. Yep.
This is impressive. All right, shout out Cloud Policy.
Yeah, no doubt, no doubt.
Nice. Okay. Thanks for sharing that. Because
No
I'm definitely
problem at
going to
all.
start this bad boy.
Yeah, bookmark it right now and check them out.
Yeah.
But the next topic was inputs, the module inputs.
Inputs. Okay.
And yeah, essentially, like I'm just reading directly from the book here. To make a function configurable in a general purpose programming language, you give inputs parameters to the function. And it's the same way with Terraform modules. It's just those inputs are essentially variables. Like that separate variable file that has all the variables that you're passing in either at plan time or apply time, or maybe you have defaults already defined. Those are essentially the function, they're peers to the function inputs, function parameters that you're passing into your Terraform module.
And it does have an example for our programming friends out there. It does have this, a foobar example where it's like, here's your function. We're going to pass a little something in there. We're of course, our function has its own little params, but you, my friend, you can pass your own in so it works in your environment. So it'll pull the examples here are, what are we going here? Input variables. Open up your variables.tf. Okay, you create your variables. That makes sense. And then you go through your main.tf and you start calling those variables in a bunch of different locations. Okay. Yeah, I read this. I know it seems like I did. I swear to God, I got notes. I was all over it.
So for the folks that are listening, she's holding up her book with post-it notes, and she got chicken scratch in the margins.
So yeah,
we believe you. We believe you.
I do my best. I do my best because I don't always take notes. Like I have a book that I, sometimes take my notes in, but sometimes it's just me and the text, and it's like, this is all I have. This is what I have. So we're gonna work with that today. All right, back to inputs. Back to inputs.
What I like about, Lisa, in my experience with developing modules, is providing defaults for inputs that are opinionated. And I've used this term opinionated. By opinionated, I mean it's what I feel like that value should be for the way that I want to use this particular resource or module. Now, your use case or opinion might be different. And it's a variable. So guess what? You can change it. If you want to just pick my default and say, okay, I'll use it that way and plan, apply, and, be happy with it, then you don't have to do anything else. You just have to pull down, the resource and run it. But if you say, well, I really don't want to use if I set the instance type as T3 micro, well, like, no, this is the production environment, so we need to have a larger instance than that. Well, you can override that input variable, and now your cluster has, more horsepower at the server level. So that's just one example.
They also, that sounds like familiar, that they had a similar example about if you're doing something in one environment versus prod, you don't mind using lesser resources in stage or test, but you want to make sure that when you're running your modules in prod, you have the size of systems and the number of instances that you need. So every environment may be different. Prod is always probably going to be the bigger of the 1, 2, or 3, depending on how many you have. But that's the great part about modules and inputs. It's like you can get very granular in here. And they had examples for stage and prod, but it also mentioned, if you were following along, where last week it had you creating a database inside of stage. It never really got to prod. So there was like, if you're feeling especially adventurous, go ahead and create your own production database and see what happens. So definitely pretty good examples in here. Like we said, in chapter 2, you were already deploying infrastructure. So he keeps that he keeps that memento going in 3 with the state and in 4 with these modules deploying to different environments. Although I think we only did an apply in stage. He didn't like go through the whole exercise, but he did point out where they differed. So
yeah, and it definitely goes to the don't repeat yourself approach, that method, because you're using the module. If in the case like he's laid out, the modules directory is separate from your stage, your production directory, but you're using the same architecture. All the resource layout is the same. You're just tweaking the parameters. You're just changing the sizes, changing the min and max size of your auto scaling group or little things like that, depending on the environment that you're running in. So that's pretty slick way to use the modules.
Cool.
All right. Moving on to module locals.
Module locals. Okay.
All right.
And
I'm in Southern California, so I'm saying locals, not locos. I've been known to use that phrase as well. So module locals.
Okay.
Yeah. Basically, they're input. No, they're not input variables, but the locals are variables that are inside the module itself. They're not exposed as an input, so you can't override them. And perhaps they may not be shared as output, so you can't even really see them. I think the corollary or peer in a function or a programming language would be like internal variables to a class.
Exactly.
Or something like that. So they're variables that you're using inside your logic, inside your infrastructure's code, definitions, configurations, but nobody from the outside can see them or modify them, and nobody from I say the outside as being the inputs, and nobody on the other side can read them or collect them from that way.
All right. It says so locals. I read this and I had to read it and kind of internalize it. Like, exactly what is it doing? Like, we already have variables, and now they're talking about this thing called local variables. So I had to kind of reread it. And I think it makes sense to me, especially in this example where they're actually it has this locals block that has a port. Any port has all these. It has all these numbers, and then you can actually reference. You can reference your locals inside your code. So inside this resource, instead of having it hard coded, because everything was hard coded when we first started, you can reference those local variables. So I have it listed here, and you're doing it inside. Are you reference now? I have it saying you're doing it inside the module where you're just doing local.http_port local. So it is the module where you're calling your local variables, correct?
Yes, that is correct. Because I mean, you could think about it like you could have a root module that calls two modules the same. Like, say you have one load balancer and another load balancer, and you want one load balancer to listen on one particular port and another one to listen on another particular port. But internally, they're both going to use port 80 for whatever reason, for their security group. I think that's the example that they're given. So that's kind of hidden away on the inside. Like, hey, if you're calling this module internally, we're going to use port 80. So we're going to go ahead and define that in our security group. You might use some other value at the top level or wherever else, but internally we're going to stick with port 80 for our ingress or egress or whatever the case is.
Okay. Very good. So I did get local variables. I didn't get a chance to go through the exercises, and that for me is always how it solidifies. Like, okay, I'm reading it and I get it, but now I have to apply it. Like update my last. You know what I haven't done? I didn't even update what we went over last week to move it into S3. So I got a lot of catching up to do. I have a lot of catching up to do, and I don't want this to get away from me, because I learned a lot in that 2-week span, because I did it. It wasn't correct necessarily. I made a lot of mistakes. Some things, were deprecated. So I had to figure things out. And that's how you learn, from the mistakes that you make when you're coding these things. So don't forget, if you're following along, actually follow along, because that's where the magic happens. And I'm saying that for myself, but I'm sure other people are the exact same way. Like, that's when it
Yeah,
gets real. So I'm
it
gonna make
really
it.
is. Yeah, and that's when you remember. I mean, when you fix something and you realize what the problem was, and the hippocampus locks it away. I don't know, brain,
Is it? I'm
regions
like,
or whatever.
did he know
It could
that?
be the frontal lobe. I don't know, but I'm saying somewhere in your brain is tucked away so that the next time you see that problem, you're like, you know what? I know this, and I
Exactly.
know how to fix it, or what to do better, or what to do differently, whatever the case is. So yeah, you gotta fix those problems and work it out.
Awesome sauce. Hey,
Yeah.
so this week, again, we talked about that this book has 10 chapters, and
Mhm.
technically we're like right almost at the halfway point.
We're
Let's
just about
take our
halfway.
temperature. Let's take our temperature.
Okay.
Mike,
Okay.
what do you
Yeah.
think about what we've learned, what we've read so far? I'd like to get your opinion on this before we because we're going further, but I want to know, like, right here. Let's get your temperature.
Yeah.
What do you think?
I really do think we've come a long way. I mean, I'm biased. I'll go ahead and admit that, because I've used Terraform at scale for many years. But I feel like somebody who's coming in, just picking up this book, wants to learn Terraform. If they've gotten this far, then they're ready to go. Like,
Awesome.
they've learned a lot. I think with uh I think the next step after learning everything that we've learned so far, and I think we'll get this in the next chapter, which is like tips and tricks, or some of it, is just like learning how to productionize your Terraform. Because
Mm,
right now we're working with local files. The modules are local path references. And pretty soon we'll talk about how to version it and how to reference it. But once you start actually deploying the code in a way that other people are depending on your resources to be live,
mhm.
I think that's when you really, really see the power of Terraform. You really learn how to productionize it, run it in production. And I think at this point we're at the we've been trained enough to be ready to
Okay.
pick up those gems down the road.
Okay. Awesome. There's actually a chapter called Taking Terraform to Production.
Well, there you go.
So that's a transitional phase from what we're learning currently
Yeah.
on our local machines to actually putting this out there where you can do production grade IAC and deploy multiple environments. And this is pretty interesting.
Hmm.
Modules and TerraGrunt. Uh, okay. So we have a lot more learning to do. So
We
our
got some
pulse,
catching up.
our pulse says that we are learning, that we are getting a lot out of this text, because again, we set off running from the first
Mm.
episode,
Yeah.
and by the end of this we will have been able to transition into production ready and understanding how we do it now, how it makes that leap into production
Hmm.
environments. I'm looking forward to that, because I've been wanting to get into Terraform to this degree for quite some time.
Yep.
So I
Yes,
am bought
indeed.
in. I am bought in. So my
Cool.
pulse, taking my pulse, I am enjoying this book. It is very well written. And if you just remove the fact that some things may be a little dated and you can work
Hmm.
around those, that doesn't take away from just how good the text is,
Yeah.
and how good the learning can be in this book. So
Yeah.
so far so good.
Totally agree.
So far so good for me. All right. Where did we
Cool.
leave off? We just went on this crazy
Um,
side.
I know, right? We were talking about locals.
Locals,
Next
right.
up are outputs. And I
Got
mean,
him.
outputs is very similar to like resource outputs. We saw how
Mhm.
to use those in previous discussion, where your resource creates something and you do your Terraform apply, and at the end of the apply, the outputs are applied. They're returned to you, so you can get to see what those outputs are. And modules at the root module level have the same sort of output, but if you're what I want to say, if the module itself exposes outputs, you can use those in other modules. You can reference them like we've been referencing with var.variable name, local.variable name. Then you have module name dot output name. And that's key, because that's how you wire multiple modules
Mm,
together to get this top level structure, where one module is creating something that another module is going to take as an input, and actually produce the whole environment.
Yep, there's an example on 128 of what you
Yeah.
just talked
Oh,
about.
cool.
Yes. And Terraform, a module can also return values. You do this using a mechanism that you already know, output variables. So yeah, they were helpful in our initial, and I can see in this example where you can access your output variables using the syntax that you just made. So in there's two resources on here. One is actually it's two separate resources, but they're both the auto scaling schedule. And the example was, say if you needed your environment to scale up at 9 a.m. and scale down at 5 p.m. So that's the example that you're going to see in the book. And I can see how referencing those outputs are helpful. You got to watch the code, but yeah.
And one thing I'll say about what like what the author is calling a global module, outputs are very, very important there, because you know that people are going to be referencing those modules down the road. And in my case, one of the key global modules is the VPC, because you don't want people to be making changes to your VPC willy-nilly with every Terraform plan and apply. So what you do is you say, hey, this is the VPC. We're just going to set it over here to the side. But what you can do is tap into this module as data, and the data will provide you with a VPC ID, with the security groups, with the what do I want to say? The good grief, I'm losing all of my VPC talk right now. The subnets. That's what I was trying to think of.
There's NACLs. There's
So everything that the VPC provides, you don't want people to change. You just want them to reference it in their deployments and their implementations. So you create your root module, which is the VPC, and then it provides all this output, and then they can read in those values into their module without making any changes to your stuff.
Sounds good.
And that's, I prefer to do it that way than reading state, to be honest.
Okay.
Yeah.
So now I'm going to dig a little deeper. I like the way that you explained it. Makes more sense. You reference it, it's already there, as opposed to going into state. What is a use case for doing it that way? What would be the reason you do it that way?
Well, and I'm sure you could argue either case, but I feel like state is written to a file and it's sitting there.
Yeah.
The way that I reference, like, if I'll just keep going with the VPC example, is that the input to this data module is a VPC ID. So you know that ID. You're saying, as the consumer, I want to reference this VPC, and here's the ID. So what that module will do is it will use a true Terraform plan, because Terraform plan does all this data collection using API calls to get the actual state of the resources. And it pulls it all the way back in down to your plan and shares those values with you. So they're more recent, they're more live, they're more actual than what a state file might provide you, if that makes sense. The state file is just written to disk at one point in time. But if you're doing a plan, you're getting the live values right here, right now, today. So you would hope that those two things are consistent, the state file and the live resources. It could be the case that they fall out of sync for whatever reason. So that's one of the reasons why I feel like, don't read the state file, but I'm sure
because the plan is the most current. If you're running that plan, you're pulling that, like you said, you're pulling that data. Even if anything happened, you ran your first whatever forever ago, referencing it fresh opposed to digging into your state. I can see an argument for both. But I like the fact that when you run the plan, it really just goes out and makes those API calls and brings all that information into it. So
if I had to be devil's advocate, I would say reading the plan file is probably faster. Because you're not making all these API calls.
Okay.
You're reading a file, you're pulling out the value, and boom, you're done. So if you're concerned about speed of your plan and apply, maybe that's a reason.
Okay. Good to know.
All righty, moving on to module gotchas, and he called out two of them:
Is it
file
more?
paths and inline blocks. Oh, there's plenty more
Okay.
gotchas.
Okay. But can you give us an example that's not in the book? Because
Yes.
I see file paths makes perfect sense.
Yeah.
Inline blocks, I won't give that away. But
Yeah.
what other gotcha can you think of when
And
using modules?
yeah, so one of the main gotchas that I've carried, since I've learned it, is using a module that you have to modify. And it's helpful if you have access to the source and can make these modifications. But say you have a module, it's parameterized, so you can pass in your own values for making your own opinionated module or overriding other people's opinions. But there may be something that's changed way deep down in that module that you really, really need to change, or you need to pass a value to. And what if the author of that module didn't expose it as an output? Or what if there's something that you need from that module and they didn't, or I'm sorry, they didn't expose it as an input, and they didn't, something you need to read and they didn't expose that as an output. So now you have to go into that module and make those changes. You have to wire up that variable that points to the value, and then you have to wire up that output that pulls the value out. And I've been in many cases where we're like, hey, yeah, we're good, we're done. And somebody's like, nah, we need to change X, Y, and Z. And I'm like, crap, that's not a variable. So now we have to go into the module, and we haven't talked about versioning, but now you're actually creating another version of that module that's different than somebody might already be using. And that's the key. That's where it burns. Because if you use this latest version or whatever the case is, then somebody who's referencing that module that you're changing, they run their plan. They're like, wait a minute, I wasn't expecting that to change like that. And now you've got a problem. So that's versioning actually helps with problems like that. But still, it's a gotcha when you're working with modules, that you really have to know what you have access to put into the module, and know what that module provides as output.
Oh, thank you for that real world example.
Yeah.
Awesome. So the two in the book, yes, gotchas, but yes, yours definitely speaks to how that could be problematic, and it's very it feels very relevant. That's the word I'm using. All right, let's talk about file paths.
Yeah, well, file paths, I've run into that as a gotcha, and I mean, it's really kind of funny too, because and we'll get into this discussion here in a minute, but working with Elastic Container Service, you have to give it a task definition. And so as we're developing these modules that use ECS task definitions, we're like, well, where do we put this file? We define the module says it's there, everything's good. But then if you're using multiple instances of the same module, then you're like, okay, are we overwriting it? Is it reading the right one? Which one are we referencing? And so on and so forth. So you really have to make sure that your path.module file is probably the most valid one to use, as opposed to the root or current working directory, unless you know for a fact that, hey, this is the path that I want to use.
Okay. And it says something about this example in the book talks about you have to use relative paths and not absolute paths. So I can see how I can kind of visualize how that would be problematic if you used an absolute path, because who's to say what your directory structure and how deep you are? It might not jive with what was expected in the module. So that's why the file paths. Let me see. I'm turning a page now. And you can reference it. So once it's defined, in your where do you put your path reference? Is it in your main TF in your modules folder? Is that where
it depends on the string that you're trying to define. So like in the example that the author uses, he's referencing this template file, and really the template file is in the module itself. It's not in your local directory. It's not in, you could reference it as what I want to say, like local references to give the actual path, but that might not be correct if you're using a CI system, for example. Works great on your laptop, but as soon as you run it in GitHub Actions, it just fails because it doesn't know where to find this file. But if you say from this path location, look for this file, or rather from this module location, look for this file, then it knows where to find it, no matter where you're running it, on your laptop or in your CI system.
Okay, good example. This one I thought was interesting, and I was like, why is it even a thing?
What's that?
Inline blocks.
Inline blocks. And I wonder if he didn't have anywhere else to put this particular example, because this is something is not necessarily important to modules. This is important across your code regardless, because it can break a lot of things in a lot of funky ways, and particularly with the example that he gave with security groups. And I'll tell you why. Inline, if you create a security group and you say this security group has a name, and then it has this ingress rule and this egress rules or whatever rules you put in it, if you go back and make any changes to that security group that cause the security group to be recreated, then Terraform will try to destroy the security group and then recreate it with a new configuration. Now, if it's just the security group by itself, it's probably not such a bad thing. But because we know so many things rely on security groups, number one, at best, your Terraform plan will never finish, because AWS prevents deletion of security groups if something is actively using it.
Yep.
Yeah, so it's going to keep running and running and running. It's going to time out whatever you have that timeout set to. And it's going to say, hey, I failed. I tried to delete it, couldn't delete it. So that's probably the worst thing that could happen. So the benefit or the solution that he provides is just creating the shell of a security group. And it's really, you don't even tell what the security group does. You just, hey, it's a security group and this is the name. And then you create resources that populate that security group independently of the security group itself. They just reference the ID.
Yep.
So then you could have all these rules, all these whatevers, and you can delete or add those as you see fit. And the security group itself is not really going to care. It's just going to exist without being modified. So that's the workaround there. So, and I mean, maybe he had no place else to put this. Maybe in tips and tricks, I think this would have been a good addition.
Okay.
But that could have made that chapter long. I don't know. But yeah, because this can affect you everywhere, not even just in a module.
So he does go on to say, using solely separate resources make your modules more flexible and configurable. Like, and if you mix them, you're doomed. Like, so you should probably be team one or team the other. And
yes,
I just you should always prefer using separate resources.
Yeah.
Okay.
Yeah, I would say if you read the Terraform documentation and you can configure a resource either inline or separately, I would say go separately.
Gotcha.
Yeah, just go ahead and use that approach. And the other examples he gives are AWS route tables and AWS network ACLs. Yeah, things that you don't want to delete. For sure.
Absolutely. Okay. That was good. So there's, like you said, there's probably more gotchas, but I can see how those can happen. Like you could screw up your file path. You could, decide, you put one input block somewhere and not realizing, that feels like a rookie mistake. That feels like, if you've been doing this for some time, you probably wouldn't have to run into that or deal with that.
Yeah, you already got the scabs and scars from the first time. Exactly. But so it's good he introduces it here because like we've been talking about, if you're just picking this book up, coming into Terraform, this is probably a good place to figure those things out before you go into productionizing Terraform, deploying Terraform at scale, that type of stuff.
Productionizing. Is that a word? Are we making it a word?
It is now. If it's not already, it is now.
Productionizing. Okay, I love it. All right, what's next? We are moving
module versioning. And this is important. Basically having different modules or different versions of your module that you can reference, because as we talked about, working with a staging environment, a production environment, you want to test on your staging or development environment without affecting your production environment. So you need different versions of your module. it gets difficult if you're using local file paths because there's no versioning. It's like whatever version is on disk, right? Really, the only thing that you can do is just wait until all your testing is done in your staging environment to run a plan and apply on your production environment, because they're both pointing at the same thing. But if you're using the approach that he mentions, putting your modules in Git, then you can use Git tags to pull. First of all, you can use Git. Terraform natively speaks Git, speaks HTTP, it speaks S3, and maybe some other like object storage languages or APIs, so that you could pull in modules from those particular locations, and then use tags and other references to pull in the specific module.
Yep, I saw that. That's pretty cool.
Yeah.
So versioning is definitely good. I discovered that. What else do we have in here? Like I haven't gone through this exercise. I need to catch up, so I can make this a little bit more concrete. But I'll definitely have to give this a try, though.
Well, I do have some slides that I'd love to share with you and the dear folks that are joining us live or listening to us on Spotify, YouTube, Apple Podcasts, Spreaker, wherever you're joining us from, MySpace, Facebook. I don't know.
Yes, my favorite.
Instagram.
My face. I had a coworker who called it my face, and
my face.
I did not correct him.
Oh, that's funny. Yeah. But hey, I mean, it feels about, well, I guess back in the day, it felt about the same, right?
Exactly. And it was back in the day. This conversation was back in the day. So
yeah, cool. Well, let me pull up my slides here, and I will get into the discussion as best as I can for the folks that are listening and don't have the benefit of seeing the slides. Yeah. So the current slide now, inline blocks versus resource definitions. And I'm just showing an example of, like, on the left-hand side, this is a security group that has this ingress rule. And if I made some changes to this ingress rule, then I run the risk of messing up the security group. On the right-hand side, I just create the security group as a shell. And then inside that security group rule resource, I reference the security group ID, and then I tell it the type of rule that I'm creating, and then I give all the parameters there. So that just makes things a little bit safer to work with in Terraform.
Looks good. All right, that was a nice visual to compare the two.
Yeah. Okay, so this is the part where I wanted to get into a real world use case of working with modules from beginning to end, as much as I can cover in, like, say 10 or 15 minutes. It probably won't even take that long. But in my case, the projects that I've worked on, we typically have stored modules in a single repository, and we release these modules to S3. We basically have a process, our build process wraps up all the modules into a zip file and stores that zip file in S3. And then we can reference that location using the source parameter for the module, and we specify this S3 path, S3::, and then the HTTPS path all the way down to the zip file. And so the cool thing about Terraform, like I mentioned, it speaks Git, it speaks S3 over HTTPS, it speaks some other stuff. So you just have to give it this URL, and it knows how to get it and knows how to access the code inside, particularly if it's a zip file. What it'll do is to say, hey, this is an S3 bucket. The environment where you're running it has to have permissions to access that bucket. Definitely make sure your buckets are private, and then give the CI pipeline or your local session or whatever permission to access the bucket. Then you can download the stuff. Terraform will unzip the bucket, and then you can access the stuff in the bucket by giving it the name of the folder where the module files are. One thing I have highlighted, and I'm calling out on this slide, is that / after .zip. That is key, and I can't state sternly enough that having both of those slashes there is not a typo. That's just how it has to be. And I'm sure it's because of the way that this URL is formed. It's the same case when you're working with Git. The Git references have .git and then 2 slashes and then the name of the module or whatever. So you just get into the habit of seeing 2 slashes right there. Don't think it's a typo. and change it in somebody else's code, and then you check that code in, and now you're breaking everything. Just understand that those 2 slashes have to be there. I can't stress that enough.
Gotcha. Okay.
All right. So we got our resources uploaded in a zip file. And then, so we talked about root modules. And this is really all that's typically in the root module, a main.tf for the root definitions, variables.tf for the inputs, locals.tf for the local variable definitions, and then outputs.tf for anything that the module is going to share to the environment. And in this case, it's usually like at the root module level, it's usually just informational. If you want to run Terraform outputs in the root, then you get all the stuff that module is sharing with you. You're probably not going to consume it somewhere else. Maybe you will if you're building like a system of root modules, then really that root module becomes a child module itself. But really, usually at the root, if that's like the terminal level, then you just want to see what that module created. And that's where those outputs kind of come into play. All right, next up. So we talked about variables.tf, and then I just gave some examples of some of the typical variables that would be passed into this module. Now, we've also talked about opinionated modules. So the modules that I was working with, almost all of these values would already have defaults. So you would only have to really have a successful deployment of this root module. You would only have to give it a name, an environment, and a VPC ID. And everything else is done for you automatically. And we'll get into that in a minute. But basically by having those opinionated defaults, it just let us deploy stuff faster. We could just have stuff spun up. If the developers come and say, hey, we need to try this thing out, we need a new environment. We're like, cool, we'll have one for you. And, give me an hour, give me 2 hours, something like that. And then we'll spin it up. We just need to know what to call it and which VPC, if it's production or non-production, to spin it up in.
Cool.
All righty. So there are modules inside main.tf. So the body of main.tf is mostly just module calls. So module VPC and then the source for it. Got some other things in there. And as we talked about, these first sets of modules that I have listed here, VPC, label, KMS, or key management service, ECR, Elastic Container Registry, and ACM, Amazon Certificate Manager. Most of these things for this particular use case were data. Like you're just giving it some sort of input to let it know where to look for the values, and then it returned what you needed. So like for the VPC, you give it the VPC ID, and we saw that was a variable to the module. It's going to give you back the subnets, public and private. It's going to give you back the access control list, whatever other information that you need to reference from the module. You could pull that out as an output. And the other one that's key here for this particular one is ECR. In this case, we instead of letting the application create its own repository, we created and this is a container registry, I should say. We created the registry beforehand because you have this chicken and egg thing where you need the registry before you could stand up your ECS service, because you need to specify the image in the task definition.
Okay.
So somewhere else, and also if you blow away your ECS service, you don't want to blow away the registry because you might lose, versions of containers that people are still using or something like that. The workaround that we did for that, like we said, all this stuff was opinionated, is that inside the ECS module, the default container is just like Nginx or something like that just says, hey, I'm a web server, I'm alive, you can reference me. And so that way everything else just kind of works, expecting something to give a 200 HTTP response on a port or something like that. And then wiring these modules together with variables. Internally, there may be some locals that I'm referencing, and then modules, if there's, again, like variables that are coming out of this VPC module, out of this ECR module, I'm using module.vpc.subnet, or something like that. And I'm passing those into these other modules. So that's how all that comes together. And then I think I got a couple more slides to go. So you might be wondering, like, hey, that's all good and fair. You got all these modules, but still, like, does anything actually create a resource? So on that previous slide, I highlighted the child module as the primary child module, the ECS Rails module. And inside the ECS Rails module, that's where a lot of the action happens, because we were deploying Elastic Container Service applications. So we needed load balancers. We had CloudWatch dashboards that showed us all the stuff by default automatically. We didn't have to go in and click ops dashboards that showed us everything. We had pipelines for deployments. All in the IAM file, we had all of the permissions and roles, and that the service would need, any other parameters that we need to pass into the task definitions. Route 53 for setting up domains and all this other stuff. Service discovery, so that we have, so other services that are standing up, they could find this service. Security groups, and then the subnets. It pulls in data from the VPC and creates whatever subnet stuff that it needs. So this is where like all these resources actually have to, interface with AWS, or Terraform uses the def configuration here, interfaces with AWS and creates all these resources. And the one that this is supposed to be highlighted, but I do have it in bold and in all caps. Almost all key resources, or almost all key resource values, we return as output, because you never know what downstream module needs to reference something inside this module. So the output file for this particular module might be crazy. It might be like hundreds of outputs, but that's to our benefit, because again, like I was talking earlier about these gotchas. It may have been the case that we deployed something and we needed to reference something in there, but we didn't have it as an output. So guess what? We got to make that change. Now we got to spin another version. So we eventually got to the point where we're like, you know what? Anything that's in here that's a resource, if it makes an output, guess what? It's coming out as an output. So that's pretty much where we got to with passing out everything as an output. So popping out of this child module back up to the root module, it has its own outputs. And as I said, these are mostly like consumed as information.
Right.
These are outputs that the root module is going to tell you, like, hey, I deployed this ECS module, this ECR module, so on and so forth. And the cool thing about the using outputs at a root module level is that you don't have to call the individual outputs for each module. You could just say output ECS, and if that module itself has its own outputs, guess what? You're getting all of them. So then you could just run your Terraform output, and it's going to show you everything that this root module produces, and everything that all the modules that it calls produces also, provided that they are defined as outputs. And cool. That's pretty much like a walkthrough of a real world module based workflow with Terraform.
This was very in depth. The descriptions that you gave, I like the idea of put it all in there. Like you'd rather, as opposed to going back down and editing and reconfiguring that module, get it all out. You never know when you're going to need it, when it needs to be referenced. I think erring on the side of verbosity is probably better than not. And I can see the value in that, depending on what infrastructure you're spinning up. So yeah, that was pretty cool. I love your little aside there. Which
one was that?
The book didn't go into this level of detail, and you went on this little aside to provide it a lot more cover and context and detail.
Yeah,
so
and I'm hoping, and that's what I'm hoping, that the author, I haven't read ahead, but I'm hoping that the author will surface some of these things in tips and trips, deploying to production, that type of stuff. Because again, these are this little discussion that we had is an artifact of years of using Terraform in the real world. I've got the scars, I got the bruises, I got the scrapes of having come across all the rough edges of Terraform in one way or another, to get it to where, like, oh, we can deploy and be pretty confident about what we're deploying and not experience any incidents or issues or anything like that.
That's good that you're sharing it. I think that's super helpful. And again, you're taking all of the experience that you have, you're sprinkling it on us, and I love that. I love that. Hey, what time is it? We've been in it And we had Tech Coach Ralph stop by.
Tech Coach Ralph is joining us live in the
that.
studio. Thanks for joining us, sir. Got to give you the salute. Yeah, so good to have people join us in the studio live and direct. That's awesome.
It is. I mean, the fact that, you know, people want to hear this, and you really dropped some good gems. I do hope at some point the book will cover it, but I think you tend to pull in those those real world use cases and those examples that, you know, maybe they won't make it into the book, but you definitely provide us with that. So good for you.
And it is
good for us. Wait a minute.
It's my honor. Yeah, I'm happy to be here to share.
Yes, well, you know what? Thank you for those bruises. You know, thank you for those scrapes. You know, you're going to help us try to avoid those mistakes. So that's pretty cool. This was a good chapter. Again,
I really enjoyed
4
it.
chapters. We're making mad progress.
Yeah, we are good. And just for reference, that was chapter 4, how to create reusable infrastructure with Terraform. And let me see, I don't think I have the name of the chapter, but next episode, tips and tricks for working with Terraform. And I want to say that is chapter 5, Terraform tips and tricks. So if you're following along, we're going to be going over chapter 5 next time. And yeah, looking forward to you know, what the author has to share as far as, you know, tips and tricks go. So I'll see if I can pull some more out of my sleeves.
I'm sure you can. So the full chapter name, because it's a long one, I'm looking here on the screen. It says tips and tricks, loops, if statements, deployment, and gotchas. So we're getting more
gotchas.
More gotchas. Okay, I feel better because they only listed 2, and you gave us a great example. So we're going to be exposed to hopefully a few more when we get into chapter 5. And chapter 5 is definitely a beefy chapter. So we're going to have to work on this one. For sure. Okay. Yeah, this is like a 50-page chapter. We're back in long chapter land. Last chapter was a respite.
Yeah, and even Tech Coach Ralph is saying that I favor CloudFormation because Terraform's giving me all these battle scars.
You need
infrastructure
to
as code PTSD. So you're gonna have to trademark that phrase, Tech Coach Ralph, IAC PTSD. Yeah, we'll talk about it offline. CloudFormation gave me some scrapes and scars too, but
I'm sure. I'm so sure. I love that.
Yeah, no doubt.
What else we got? Anything else? I'm looking forward to picking up where I left off and working on deploying into my stage environment. I don't think I'll do the prod, not necessarily to do it twice, but if I get it right the first time.
Yeah. I think the only thing that I would recommend, if you are using the S3 bucket or the remote state, maybe try to do like some kind of version thing just to kind of get a feel for it. Yeah. So then if you do deploy stage and prod, then maybe you can reference one version in staging, do another version in prod, make a change, see that change in staging before you see it in prod, you know what I mean? And then work it that way. Otherwise, it's 6 on one, half a dozen on the other.
So this is the chicken and egg thing, right? We talked about making sure that your bucket is there before you can use your bucket as state. In that IAC file where you're creating the bucket, you're going to go ahead and configure versioning, and I'm assuming there's other best.
Well, I was talking about module versioning.
Oh, I'm sorry. Right.
You're talking about state versioning. Yeah.
Okay. I'm still back in chapter 2.
No, it's all good.
Chapter 3.
But what you could do if you want to mess around with state versioning, and this is like really, really extra credit, is like break something or like do something funky with your state file. So your Terraform plan says, hey, I want to recreate everything, or I want to delete this stuff. And you're like, no, wait. And then restore that version of state from the previous version if you turn on versioning when you create your bucket. And then try it again and make sure Terraform comes back correctly. That's another gotcha that I've had to do as well. It's not fun, but it is there. It's like an escape hatch if you need it.
I've seen plenty of films where the escape hatch is what saves everybody. So we're getting a little bit of that in Terraform as well. Well, that's what's up. I'm looking forward to chapter 5.
Cool. Yeah, likewise.
So we did it.
we come to the end of another good discussion. Angela,
Always.
it's always great catching up with you, chopping up the
I'm
cloud
learning so much.
topics. Yeah. And I'm glad everybody else is here to learn along with us. Yeah, that's probably the most fun part of this whole thing.
It is. It is. So thanks for joining us. Thanks for riding with us and checking in and, being a part of the conversation. Even if you're not reading along and you're just, you have your own experiences that you're sharing, we do appreciate that input. We really do. And thank you for doing that. So that's it for me. I'm this blank slate where I'm just taking on all of the gems that this book and you have to offer. So it's not bad.
Cool. My heart and mind are clear as well. So I'm good to go.
Awesome. Have a good one, everybody. We'll see you
All
soon.
right, we'll see you. Yeah, we'll see you soon. Bye.
Bye.